Now that we have a working solution, let's improve this project by incorporating dynamic incremental loading and dynamic backfilling. Let me first move to the script before I continue. So here we have our pipeline uploaded in Kestra, and if I were to scroll down to the configuration specifically for these two endpoints, issues and forks, you'll notice that for both of these endpoints, the dates that we're providing are hard-coded, right? So you can see here we've got 1st of July, and here is the same date. Now, while this is a viable setup, it's not optimal. And the reason is, if I ever want to change the initial value, for example, for incremental loading, I would always have to come to this script and tweak this value myself. And similarly for the forks endpoint, if I want to turn on backfilling or turn it off, or if I want to change the time window for the backfilling, I'll always have to visit the script and manually enter those values. And that's not really a best practice. Ideally, we should be able to change our parameters or toggle on and off different features without touching our scripts. So that's where dynamic incremental loading and backfilling comes in. With these two features, we'll be able to change these parameters without having to, tweak our Python script. So let me start with dynamic incremental loading. So after we create this source object, which we called GitHub source, I'm going to be adding both dynamic incremental loading and dynamic backfilling. So I'm just going to say dynamic incremental loading and dynamic backfilling. The cool thing about DLT is that you're able to tweak or change your configuration even after creating your source object. So that's exactly what we're going to do now. So currently, our GitHub source object has hard-coded values, but we can add some extra code to change that. So for incremental loading, this is what it's going to look like. So first, if I haven't already, okay, I've already added the OS library. Basically, what I'm going to do is I'm going to replace the hard-coded values with environmental variables. I'm going to create for incremental loading the initial value variable. So I'm going to call it initial value. And this is basically going to access an environmental variable called issues initial value. We haven't created this yet, but we'll get to that. So now that we've created this environment variable and this variable, we can replace this hard-coded value, which is right here, with this newly created environment variable. So I'm going to do that right now. So firstly, I'm going to type GitHub source dot, and now you follow with the name of the endpoint. In this case, it's issues. And then we use a function called apply hints. And inside, I'll say incremental, which is the name of the parameter. And I'll say dlt.sources.incremental, another parentheses. And I'll say cursor path. I believe this should still be updated at. Let me go up. Yep, I can just actually save some time by copying this. And I need to get rid of the quotations here. Great. So we're applying our hints. We've provided a cursor path, and we're now supposed to provide our initial value. Like I said, instead of a hard-coded value, we're going to be providing our variable, our environment variable. And that's it. Just like that, we have switched our hard-coded values with, a dynamic variable. So now anytime we want to change the initial value for incremental loading, we don't have to touch the script. We can just go to the KV store and then just change the value. So I'm going to apply a very similar logic for the dynamic backfilling. So I'm going to say, and again, this is for the forks endpoint. Let me actually rename the comments to make that clear. So This time backfilling uses a time window, so we need a beginning date and an end date. So I'm going to say forks initial value equals to os.getEnv. Forks initial value will be the name of the environment variable. And unlike the incremental loading in issues, backfilling is optional. We don't need to specify a time window if we don't want backfilling. So rather than stopping here, I'm going to provide it a default value of an empty string, and that'll come into play in a minute. So I'm going to do the exact same thing, but for the end value. So I'm just going to replace initial with end. And there we go. And now I'm going to perform the same exercise here in which I replace the hard-coded value with the environment variables. So I'm going to say GitHub source.forks. Again, that's the name of the repo. Apply hints. And then incremental is equal to. And now here I can just copy and paste the parameters that have already been added just to save some time. Oops. I forgot to add some parentheses. Let me try that again. And now I just need to get rid of the quotations. There we go. Now I do need to add the end value as well. So I'm going to say end value is equal to and forks end value. And I'll replace this hard-coded value here as well with forks initial value. And I just noticed this as I was typing, but I'm supposed to be using the equal sign, not the semicolon, for this incremental function. So let me fix that for myself really quickly. There we are. Now we're almost done, but once again, this is an optional feature, right? Sometimes we're not going to want backfilling. Usually we don't want backfilling. It's a one-off task. So we want to create logic that makes sure that we'll only run the snippet when we have assigned our initial value and end value in the KV store. And the way to do that is simple. We can just make sure that neither of these values are blank. The way we can check that is with a simple if statement. I'll say if forks initial value and forks end value. And I'll just put this entire snippet inside this block. And that's it. So only if I assign an initial value and an end value for the forks endpoint will this snippet run. Otherwise, it'll just run as is. So I'm almost done with applying the dynamic incremental and incremental loading and backfilling. I just need to provide the variable for the initial value. Okay, so I've added my issues initial value environment variable. So if I just open this up, you'll see that I've set it up to be the 1st of November 2025. And that basically means that if I were to rerun my pipeline again, it's only going to be collecting issues that were recorded from this date onwards. So it's going to make for a faster pipeline run, basically. So let me save this, and I'm going to run the exact same flow again. Again, nothing has changed for this flow. The only thing we've modified is the Python script itself. I'm not sure why it's not loading. There we go. So let's execute our flow once more. Ideally, nothing goes wrong. Let's find out. I'm going to execute. Once again, it has to build the image before it runs the pipeline. Oops, we have an error. Let's see what happened. Ah, a syntax error. Let me go back to my script and see where I went wrong. I see my mistake. It's a pretty simple one as well, I believe. So I'm supposed to include dlt.sources.incremental instead of just the parentheses, otherwise that would make it a tuple, and that makes no sense. So let me save this and let me try run that again. Okay, attempt number 2. Okay, thank goodness. This one managed to run without error, so that's great. And quick side note, if you're trying to type along and you're struggling, just know that everything that we're creating here is going to be in a GitHub repository that you can access later. And this includes our flow config and our Python scripts. So you can always use those for reference if you're struggling to replicate what we're doing here. Let me click on this so that I can inspect the logs. And if I scroll down here, you can see once again, we're doing the same extract process, but you'll see that this time, while all the other data items for repos, contributors, releases, and forks are going up, our issues remain at 5. And this is naturally because of the new incremental loading that we set up. So the hard-coded value that we used before was at the 1st of July. Now we've set it up to be the 1st of November, and that means we're only collecting records from November onwards. And given the current date, that's not a lot of time. So it makes sense that we're only collecting 5 issues for this pipeline run. And that also explains why the pipeline ran quicker this time, because there were just fewer records to extract. We can further improve our project by leveraging parallelization. In Kestra, parallelization is going to look a bit different compared to the other orchestrators. After all, in our local deployment, all we did was run the exact same script in a Kestra server. To enable parallelization, all we need to do is first modify our current script such that instead of collecting data from all the endpoints, it'll only collect data for a single endpoint. And we can run this exact same script 5 times concurrently. But each worker is going to be assigned to a different endpoint. That way we can collect data from multiple endpoints concurrently and instead of sequentially, i.e. one after the other. I'm going to show you what that looks like in practice. Okay, so we are back in Kestra. Now, like I said, we're going to be modifying the script to make parallelization feasible in Kestra, but I actually think it's better if I just create a new file just so I can preserve the work I've already done so far. So I'm going to say Kestra pipeline parallel.py. And what I'm going to do is I'm just going to take all this data or this code and I'm going to put it here. And to this code, I'm only going to make a few changes. So firstly, I want this parallel pipeline to only collect data for one endpoint per run. And a very easy way to enable this is by basically creating a flag such that instead of just saying Python, pipeline.py, I can also add a flag that will denote the endpoint that I want to collect the data for. And what that means is I can run the same script 5 times, but with slightly different arguments for the flag. And that means I can concurrently collect data from multiple endpoints and as a result, reduce the runtime. So the first thing I'd want to do is I want to create that flag and I'll call it resource. And then after, a user provides their endpoint of choice, I want to actually omit all the unwanted endpoints from the config. So let's start with creating a resource flag. In Python, this is very easy to do. We can use a library called argparse. So I'm just going to import that here, argparse. And I believe this is a built-in library like OS, so I don't have to set up any installs or anything like that. So now let me create my argument parser object. Next, I'm going to actually be creating my flag itself. Okay, so unless I missed anything, this simple snippet here should help me create my flag. So I'm calling this flag resource. I'm making it mandatory because from now, for this script, I want to make sure that we're only collecting one endpoint state at a time. And we're giving it the 5 different choices to select from. So the script has to run, when the script runs, it has to collect data from one of these 5 endpoints. Now, once the user picks one of these 5 endpoints, we need to make sure that we're filtering out all the other endpoints from our source config. And thankfully, this is actually quite doable with DLT because they have a very nifty function for this called with resources. So I'm going to use this here. And that's it. So what we now have is a script that's only going to collect data for one resource. Our next step is to create our flow that will use the script. And we're going to set it up so that it runs 5 times concurrently with one worker dedicated to one endpoint. One more thing we need to do before we can write our new flow is we need to add one more environmental variable. Since we're working in parallel, we have multiple workers building pipelines at the same time, and that runs a risk where if multiple pipelines try to create a data set in BigQuery, because there isn't one at the moment, if multiple workers attempt to create it together, that'll return an error. So what we need is for these pipelines that are running simultaneously to share the same volume so that we can avoid this from happening. So I'm going to create what we call DLT pipeline dir for directory, and I'm just going to give it a value. So I'm going to call it var DLT state. It really doesn't matter what value you assign. What matters is that all of these pipelines that we're running simultaneously share the same state, such that if one pipeline creates the data set that doesn't exist, the others won't need to do it as well. So I'm going to save. I'm going to define my namespace first, and then I'm going to save. And now we can work on our flow. Okay, much like our Python script, I also want to create a new flow just to preserve my previous work. So I'm going to create a new flow. And the good thing is we can actually reuse some of the work that we did in the original local deployment. So the first steps, which are basically creating the Docker image, as well as the trigger, which is setting it to run every day, that part is still the same. So I can just copy that logic from our older flow. So I have copied and pasted that section of the flow, and I've just changed the ID. But now this is where things are going to be a bit different. In our original local deployment, we would here, after building an image, write our task that's going to run our Python command. But before that, we actually want to create our parallelization logic. And in Kestra, we can do this with a tool called for each. And what that basically means is it helps us iterate over a set of given values. And it can help us do this in parallel. So in our case, we want to iterate over each of our endpoints, and we want to do this in parallel. So we're going to be building a for each task. Okay, so here we've defined our for each logic. So I've called it fan out controller because of course we're fanning out, and we're iterating over a list of endpoints, which you can see here from repos to releases. And we've set the concurrency limit to 5 because we only need 5 workers, 1 for each endpoint. And now inside this task, we're going to be creating another task. And this is going to define the instructions that each of the workers have to follow. So of course, we'll be creating a Python command task here. Okay, so I've built the Python command task that each of the workers are going to execute. And we're using the same logic, so I'm just going to gloss over this really quickly. Of course, we've set our ID to run one resource. The type is going to be a Python command. And once again, we're using the image that we created beforehand in the previous task. Main differences are, of course, the new environment variables we're using. Firstly is the issue's initial value, which is from the dynamic incremental loading. And the last one is the one we just created so that the pipelines can share the same volume. And finally, we are running our actual Python command. So the main differences are, well, we're using a different file, firstly. And second, it uses a resource flag, which denotes the endpoint for which the pipeline will run. So each of the 5 workers will run the exact same Python command, except for the assigned value for the resource flag. So when I execute this, we're going to have ideally 5 workers running simultaneously, but each collecting data for a different pipeline. So let me save this and execute, and we'll see what happens. Okay, so let's break this down very quickly. We have our build image task right here, of course, and you'll notice that instead of 5 workers, we have actually 6, and that's just because here this fan out controller that we created is actually also counts as a worker. But of course, these are the 5 workers that are actually running pipelines. And if you want to inspect the logs, you can of course just click on them and just see all the values that are being collected in our case. And now if we want to confirm that the pipeline ran successfully, we can also go to the BigQuery database. So I'm going to do that right now. There we go. So we have GitHub data Kestra, and now we also have GitHub data Kestra parallel. And if I click on this, you can see all of our tables. If I wanted to preview, of course, let's say for this time contributors, I can just click on preview and we can see all of our data.